Welcome. In this week, we talk about query processing, and the most important thing in query processing is that suppose you write a high-level query, SQL, and what happens to when it is passed to the query engine. So let us look at our discussion, what we like to discuss here. The query processing, we have a declarative SQL query, and then that SQL, high-level SQL, will be generated, will be parsed into relational algebra expression, and finally you will actually have a query plan. So query plan, that means you will be actually developing this query plan by the database management system to understand which one is best. So our focus actually is a relational system because the data is organized in tables of relation. And take a look at SQL, you're all familiar with. In SQL, structured query language, we basically focus on three operations. We say select, project, and join queries. And select, project, join queries are like this. You have a selection list. This selection list are list of attributes that you are finally going to display from which tables and where you have certain conditions to meet. So if you take a look at here, there is a relation R, which is three attributes. You are selecting B from R, where the attribute value of A value of R is equal to C, and the C value of R is greater than 10. So this is the kind of query you are familiar with already. But when we actually do select, project, and join query operations, if we are joining two relations, for example, we have R and S relation, what we look at is that what are the common attributes we have? Because the common attributes we have to always equate. For example, R.C is equal to S.C. We are putting a condition, it's actually conditional join. That means we put up a condition and join two relation to come up with our result. Take a look at this one. We have R having three attributes, and these are the tuples. We have 5 tuples, and S we have 3 attributes, and also we have 5 tuples. And you can see that in both R and S, the C is common. So when we combine, we take a look at the common attribute, and that must be equated. So this is the kind of results that you see. When they are equal, you only get those tuples. And always remember, if you do not say select distinct, you will have duplicate. Otherwise, generally, duplicates are there unless you say select distinct. If you say select, you will actually have duplicates, but unfortunately, we don't have any duplicate value here. So how do we execute this code? This is something very, very important because sometimes you face this kind of question in your class test. So what happens here? One idea, first of all, you can understand that in relational algebra expression, the first operation takes place is from, which we call actually Cartesian product. That means the from operation is actually Cartesian product operation, which is between R and S. And this Cartesian product, you apply this condition on the Cartesian product to select those and finally project. So what happens? Do Cartesian product, that is the innermost operation, and then you select the tuples, apply where condition, and then finally do projection, apply select BD. So the innermost operation is from, then immediate outermost operation is where, and then final operation is select. Take a look at this one. You are taking a Cartesian product of R and S, and then this is the first product. That means R times S. You are just simply multiplying the each row of R with each column of S, and then finally you have actually, ultimately you got that one. So relational algebra can be used to describe the plan. So plan 1, what we are doing, we are taking a Cartesian product first, and then applying a selection condition. I will actually have a different description of this relational algebra so that you understand this lecture very easily. And finally, projection operation. Now, this plan 1 may be very expensive. Why? Because if R and S is a very big set, when you multiply, it's going to be very, very big set. So the selection will take more time, and this Cartesian product will take more time. So we have to optimize that. How we can optimize? We can optimize by projecting, by selecting this. That means we are taking a natural join. We can actually have Cartesian product, then we project, and then we finally select. So what happens in this? can be discard plans. This is the earlier plan, but what we can do now, we can actually have applying this condition and finally projection. But take a look at the second plan, plan 2. What we do, we separately select from R and S and then take a natural join and then project. So natural join is going to take less time. This selection is also going to take less time compared to the earlier plan. So this plan is better plan. So we actually develop query plan before we actually execute and find the cost of each of the plan. So here what we do is practically this, and then you can see that when we actually select a set, we are applying a condition on the set R, we get this, and we are applying a condition on set S, we get this, and finally we take a natural join. So that takes less time. So plan 3, you can have both index file and then index to select, because that's also going to be a little bit faster. Eliminate S and then join R and S tuples. So for example, here we have an index file, A and C is indexed, and then based on the index file, we basically have these two, and then when we actually take the output, is very easy. The next tuple comes in. So what happens in the query processing? You give a SQL statement. That means you are saying select star from student. It's going to be parsed, creating a parse tree, and then this parse tree is going to help us to write many queries. So query rewriting is taking place based on parse tree. Query rewriting, after query rewriting, you actually find out which query is effective. So develop a logical query plan. And based on that, once you have a logical query plan, then you develop a physical plan based on the data statistics. And then once you get the statistics, you develop physical query plan and finally execute. So please remember this 4 steps is very important in query processing: parse, query rewriting, physical plan generation, and execute. So query optimization actually is taking place between query rewriting and physical plan generation. And finally, query execution between physical plan to result. So an example query like this, we have a selection of attributes from 2 set where this condition is true. And you can see the parse tree, what happens. Select from where, SWF. Select, then you have a select list attribute. You can have further select an attribute list. You have to have some exercise. From list, relation names are coming. So relation, and then from list again relation. If you have another, for example, another relation, then again from list relation, where then you put the condition and condition. So condition, you may have attribute operator and then the value constant, attribute operator attribute. You can have attribute operator constant or attribute operator attribute. So along with the parsing, you do semantic check whether it is right or wrong, because semantics, if the meaning is not correct, then it's not going to be executed. You expand the views. So what happens in the plan? You have a query rewriting, means you have an initial logical plan, you rewrite rules, and then find the best logical plan. That is actually happening in the query rewriting. And then finally, you have an initial logical plan. You can see here, that's the initial plan. That's the relational array representing this tree. So please remember, we need to understand that how we develop a tree. From here, we have a Cartesian product. So this is the innermost product, the innermost operation, Cartesian product. And then immediately we apply a condition, and then finally selection. So query rewrite happens like this. You can actually transform this into this. So you have a better, optimization. You can apply further rule like this. You can apply further rule like this. So what happens? You have an initial logical plan, then rewrite rules, develop more logical plan, find out which one is the best. So that's all from this discussion of query processing. We will go back to our next discussion is